Alright, welcome to 3-2. Today we're looking at this thing called L'Hôpital's rule. Yes, L'Hôpital is actually the name of the mathematician. It's also French for the hospital, so you figure it out. Anyway, so what L'Hôpital's rule is going to do is it's going to give us an application of the derivative that will actually allow us to evaluate certain types of limits. Now, if you think about it, that's a little bit strange since derivatives are based on limits, and yet now we're using derivatives to evaluate limits. So it is kind of a weird little situation we've got here. But what you're going to find is that L'Hôpital's rule is a very useful and very powerful tool for us to evaluate limits. And typically on the AP exam, particularly on the multiple choice sections, you are going to encounter limits where L'Hôpital's rule is definitely going to come in handy. Okay, so just as a quick refresher, remember way back in Unit 1, if I had a limit such as the one that you see here, so evaluate the limit as x approaches 3 of x squared minus 9 over x minus 3. So hopefully you remember that the first thing you should be doing is direct substitution. And if you did direct substitution here, you are going to get 9 minus 9, which is 0, over 3 minus 3, which is also 0. And remember, 0 over 0 is an indeterminate form. So that means we can't evaluate the limit with direct substitution, and we need to try something else. And with rational functions, hopefully you remember that that something else would mean to factor and then simplify. And now that I've simplified, now I can evaluate this limit using direct substitution. That's just going to become 3 plus 3, which is 6. Okay, so sometimes when we had indeterminate form, we needed to try something else. And so what L'Hôpital's rule is going to do is it's going to give us an alternate way to evaluate a limit that yields an indeterminate form. The nice thing is, not only would it give us an alternate way of evaluating these types of limits that you've seen before, but it's also going to allow us to evaluate limits that give us an indeterminate form where we actually still don't have any other method we could have tried. So before we do that, let's just take a look at what L'Hôpital's rule says. Alright, so here's what L'Hôpital's rule says. Let f and g be functions that are differentiable on an open interval containing c, except possibly at c. So we don't really care what happens to the derivative of f or g at c, just as long as f and g are differentiable around c. So if that's the case, then if the limit as x approaches c of f of x over g of x yields an indeterminate form, and I'm going to talk a little bit more about that in just a moment, then the limit as x approaches c of f of x over g of x is going to be the same as the limit as x approaches c of f prime over g prime. So in other words, if you find the derivative of the numerator function and the derivative of the denominator function, and you evaluate the limit as x approaches c of that quotient, you're going to get the same result. Now, real quick word about indeterminate form. So you already are familiar with 0 over 0. Another indeterminate form that you could end up with is infinity over infinity. Another one you could end up with is infinity times 0, or 0 times infinity, either way. And another one you could end up with is infinity minus infinity, which, remember, that's not 0 because infinity, a number could increase without bound at a different rate. So these aren't necessarily the same values. Okay, so these are some different indeterminate forms, and if you end up with any of these, then you can apply L'Hôpital's rule. Now, some of you might be thinking, well, how can you get times or subtraction if we're dealing with a quotient? And that just has to do with different ways that we might be able to rewrite that quotient. Okay, so this is what L'Hôpital's rule says, and let's just look at a few examples where we might be able to apply it. Alright, so here we go. So we're going to evaluate each limit. We're going to use L'Hôpital's rule if possible. And remember, it's only possible if you have the limit as x approaches c of f of x over g of x, and it yields an indeterminate form. Okay, but regardless, we are still going to start evaluating all of these limits the same way we always have, which is with direct substitution. So for example A here, the limit as x approaches 0 of this function here. If I substitute in, I'm going to get 0 over 2, which is not indeterminate form. That's just going to be 0. So just a quick reminder that you are still trying direct substitution first. All right, next one. Okay, this one should look familiar. This is the one that I just refreshed your memory with in the very beginning. Remember, we already knew that the answer was going to be 6, but let's just look at what happens now. So we have the limit as x approaches 3 of x squared minus 9 over x minus 3. Again, if I were to use direct substitution, I do get 0 over 0, which is my indeterminate form. So that means, according to L'Hopital's rule, I can now evaluate this by doing the limit as x approaches 3 of the derivative of the numerator divided by the derivative of the denominator. Now, you don't normally have to show that step that I just wrote, but just for the sake of illustration, I wanted to make sure it was clear what I was doing. Notice we are not using the quotient rule. This is not about finding the derivative of the entire function. We're finding the derivative of the numerator and the derivative of the denominator just so we can apply L'Hopital's rule. Okay, so this now becomes the limit as x approaches 3 of, so the derivative of x squared minus 9 is just going to be 2x, and then the derivative of x minus 3 is just going to be 1. And then now, if I use direct substitution, I get the limit as x approaches 3 of 2x over 1. Well, that's just going to be 2 times 3, which is 6, which we already knew it was supposed to be. So that's L'Hopital's rule so far. So now let's take a look at this one here. So we have the limit as x approaches 0 of e to the 2x minus 1 over x. All right, so again, direct substitution. That means I'm going to have e to the 0, which is 1, minus 1, which is 0, and then over x, substituting the x with a 0. So we do end up with 0 over 0 once again. So this is indeterminate form. Now, earlier though in Unit 1, this is not a rational function. It is a fraction, but it's not quite the same because the numerator is not a polynomial. It's not a radical function, so I'm not going to use a conjugate or anything like that. This is not a function that you'd previously learned what alternate way you would use if you get indeterminate form. So this is a situation where we actually don't have much choice but to use L'Hopital's rule. We would not have been able to really approach this very easily previously. All right, so using L'Hopital's rule, this now becomes the limit as x approaches 0 of. Now, for the numerator, remember this is e to the u, so we do have a little chain rule here. Remember the derivative of e to the u is e to the u times the derivative of u, which would be a 2, minus the derivative of 1, that's just a 0, over the derivative of x, which is 1. Again, just to clean this up, you don't have to show this step, but this is now just going to become 2e to the 2x. And so now if I substitute this in, I'm going to get 2e to the 0. Remember, e to the 0 is just 1, so I just get 2. So this is an example where L'Hopital's rule almost becomes necessary because we didn't have another way to do this previously. All right, next example, we've got the limit as x approaches infinity of x squared over e to the x. All right, so again, direct substitution, well, infinity squared, that's going to still be infinity. E to the infinity, remember exponential functions just continue to increase, so this is also going to be infinity. So this time I do get infinity over infinity, which as you saw just a little bit earlier, this is considered another indeterminate form. So we can apply L'Hopital's rule here. So we have the limit as x approaches infinity of the derivative of x squared is going to be 2x over the derivative of e to the x, which is e to the x. And so now we can try to use direct substitution again. Well, that's going to be 2 times infinity, which is infinity, e to the infinity, which is again infinity. So using L'Hopital's rule still gave us an indeterminate form. But remember, as long as you're evaluating a limit that gives you an indeterminate form like this, we can use L'Hopital's rule still. So in other words, this is an example where L'Hopital's rule can be applied more than once. So the original function, when we found the derivative of the top and the derivative of the bottom, it yielded another function that also gave us indeterminate form. So now we're going to use L'Hopital's rule again. So I have the limit as x approaches infinity of, so the derivative of 2x is now just 2, and then the derivative of e to the x is e to the x. And so now that means I'm going to have 2 over infinity. And if you recall from Unit 1, if I have a constant divided by an increasingly large number, remember that that approaches 0. So sometimes, as you can see from this example, sometimes L'Hopital's rule can be used multiple times before you finally get a response or a result that is not indeterminate form. And let's just look at one more here. So we have the limit as x approaches infinity of e to the negative x times the square root of x. And hopefully right off the bat you're recognizing that this looks very different from the previous ones. Notice I don't have the limit of a quotient. However, I do have, in my product here, I do have one negative exponent. And as we hopefully remember, a negative exponent can be rewritten as a positive exponent by moving it to the other part of the fraction. So in other words, I can rewrite this function as the limit as x approaches infinity of the square root of x over e to the positive x. And now we have something that looks a little bit more familiar. So now if I use direct substitution, I am going to get infinity over infinity, which is an indeterminate form. So now I can use L'Hopital's rule. So this is going to become the limit as x approaches infinity of, now remember square root of x is x to the 1/2, so its derivative will be 1/2 x to the negative 1/2 over the derivative of e to the x, which is e to the x. And now I'm going to go ahead and rewrite this. Remember, this 2 drops down to the denominator, as does this x to the negative 1/2. So this all becomes 1 over 2 e to the x square root of x. So now that's just going to become 1 over an infinity, and that's going to be 0. All right, so this is L'Hopital's rule. As you can see, it's a pretty nifty and handy little tool that we can use if you're trying to evaluate a limit. All right, good luck.